Plants use many types of pumps to move process liquids. One of the most common types of pumps in use today is a centrifugal pump. A centrifugal pump uses one or more impellers to create a centrifugal force that pushes the process liquid through the pump. While there are a number of different types of centrifugal pumps, they can be grouped into two basic categories: single-stage pumps and multi-stage pumps. Centrifugal pumps use centrifugal force to move liquids. Centrifugal force is the force that exists when an object or material moves in a circular motion. This force causes the object or material to move outward, away from the center of rotation. In a centrifugal pump, what moves outward is the process liquid. We can see how a centrifugal pump works by using this simplified illustration. All centrifugal pumps have an inlet, a casing, and an outlet. Inside the pump's casing is an impeller. It has a series of curved vanes that extend out from its center. The pump's casing is designed so that the area around the impeller creates a gradually widening spiral channel. This widening channel is known as the volute. Since this pump has only one impeller and one volute, it is referred to as a single-stage pump. During operation, a driver rotates the impeller, creating a centrifugal force that throws the process liquid outward into the volute. The outward movement of the liquid causes two things to happen. First, it creates a reduced pressure area at the suction eye of the impeller. This area of lower pressure draws more liquid into the pump and provides a constant flow of liquid. Second, it causes the liquid to gain speed. This happens because as the liquid is forced to the outside of the rotating impeller, it must move faster to keep up with the impeller. As the liquid flows away from the impeller, it spreads out to fill the volute. The expansion in the volute causes the liquid to slow down. The expansion in the volute causes the liquid to slow down and its pressure to increase. The increased pressure moves the liquid through the discharge of the pump and then on through the piping systems of the process. One way that centrifugal pumps can be categorized is by the way liquid flows through them. Three common flow path classifications are radial flow, axial flow, and mixed flow. In centrifugal pumps that have a radial flow design, the impeller causes the liquid to make a 90-degree turn and flow outward, or radially, from the suction eye to the tips of the vanes. A radial flow pump takes advantage of the maximum amount of centrifugal force that the impeller develops. Generally, radial flow pumps are capable of higher discharge pressures, but they don't move as much liquid as other types of centrifugal pumps. In centrifugal pumps that have an axial flow design, the impeller moves the liquid through the pump along a path that's parallel to the pump shaft. In this type of pump, the liquid is moved mainly by the propeller action of the impeller's vanes. This impeller uses only a small amount of centrifugal force to move the liquid. As a result, the discharge pressure of an axial flow pump tends to be lower than that of a radial flow pump. However, an axial flow pump may be able to move large quantities of liquid. Mixed flow pumps combine the characteristics of radial flow pumps and axial flow pumps. They use centrifugal force and the propeller action of the impeller's vanes to move the process liquid. For that reason, a mixed flow pump can develop a relatively high discharge pressure and still move a large quantity of liquid. In some installations, it's often necessary to keep a pump's driver above the liquid while the pump is submerged in the liquid. One type of centrifugal pump that you may find in these applications is a vertically mounted centrifugal pump. We'll use this illustration of a vertically mounted centrifugal pump and its driver to see how this type of pump works. The pump itself is submerged in a tank containing the liquid being pumped. The driver, which is an electric motor, is mounted above the pump on top of the tank. Its shaft is connected to the pump shaft by a coupling. This pump shaft is much longer than those found on most other centrifugal pumps. On any pump with a long shaft, it's important to keep the shaft in its correct position. so that the pump will operate properly. So several bearings are used to keep the shaft properly aligned. Now, on this pump, there is no suction piping. Instead, the suction of the pump is submerged in the liquid being pumped. The suction is covered by a strainer, which prevents trash or debris from clogging the pump and causing excessive wear. The pump's impeller is also submerged in the liquid. This helps to ensure that the pump is always primed. This means that the casing is filled with the process liquid. During operation, liquid is drawn in through the suction and then pumped through the discharge piping, which extends up and out of the tank. All centrifugal pumps work by creating a centrifugal force. This force moves the liquid through the pump and increases the liquid's pressure. In applications where large increases in pressure are needed, multi-stage centrifugal pumps are often used. A multi-stage centrifugal pump contains two or more impellers and volutes in a single casing. Here's a simplified cross-section of a three-stage centrifugal pump. Each stage of the pump has its own impeller and volute. In the volute, the liquid's pressure increases. Each of the first two volutes discharges into the suction eye of the stage that follows it. The third stage volute discharges into the pump's outlet. So in this pump, the liquid flow path is from one end to the other. This is a five-stage pump. It has 5 impellers and 5 volutes. The first 3 stages are located here, and the 4th and 5th stages are located here. But as you can see, the liquid's flow path is different from that of the 3-stage pump we just saw. In this pump, liquid enters through the suction and flows into the impeller of the first stage. This impeller has a suction eye on both sides and is often called a double suction impeller. From the discharge of the first stage volute, the liquid flows into the second stage suction eye, then out of the second stage discharge and on to the third stage suction eye, and out of the third stage discharge to the suction eye of the fourth stage. The liquid from the fourth stage is routed to the suction eye of the fifth and final stage. After the liquid passes through the fifth stage, it leaves the pump through the discharge piping. Regardless of how the impellers on a centrifugal pump are arranged, or how many stages a pump has, the liquid's pressure increases as it passes through each stage. This creates a thrust across the impellers in each stage. This thrust, known as axial thrust, is caused by the difference in pressure between the suction eye and the volute. Because there is a difference in pressure across the impellers, axial thrust is created, and it tries to push the pump shaft toward the suction eyes.